Good morning, everyone. We are delighted to dive into our journey of understanding the chemical effects of electric current. We will cover a variety of topics and explore the way electricity behaves when interacting with chemical substances. We hope you enjoy this presentation and come away with a better understanding of electricity and its chemical effects. Let's get started. Electric current can have both powerful and subtle effects on chemical systems. This slide is about two types of conduction testers used to assess the material's capacity to conduct electricity. A conduction tester with a torch bulb is made up of an electric cell and a torch bulb, where one terminal of each is connected by means of a wire. On bringing the other terminals into contact with a material, if the material is a good conductor, the bulb will light up, otherwise it won't. The second type of conduction tester is the circuit's S3 checking tester, which is able to measure a bigger range of conductivity. In both cases, having knowledge of the material's capability to carry electricity can ensure efficient usage of electric current. LEDs, or light-emitting diodes, can be a great option for testing the conductivity of a circuit. Unlike bulbs, LEDs do not require a lot of current to work. This makes them suitable for circuits with a weak current. Additionally, LED diodes create a specific colored light, depending on the type of circuit, so they can help detect many different kinds of conductivity. Electric current can have a powerful effect on other materials, which can be easily demonstrated by using an electric conduction tester. To construct one, you will need a battery, a wire and a magnetic compass. When an electric current runs through the wire, the needle of the compass will move, indicating the presence of an electric current, and it can even help measuring the current. This experiment is great for teaching children about the power of electricity. Electricity has different effects on solids due to their electrical properties. Metals such as copper, steel, iron, and aluminium are good conductors of electricity, while wood, plastic, rubber, and glass are poor conductors. Depending on the electrical properties of the material and the amount of current passed through it, the effects of electricity on these materials can vary. For example, when an electric current is passed through copper, chemical reactions may occur that change the material's basic structure. Electricity has an effect on various liquids, some of which serve as excellent electrical conductors and some of which are poor conductors. Tap water, salt solutions, hydrochloric acid and sodium hydroxide are some good conductors, while distilled water, sugar solutions, kerosene, and spirit are poor conductors. Electrolysis is the process used to examine and observe this phenomenon. Electric current has the capability to spark chemical reactions, termed the chemical effect of electric current. Passing electric current through a conducting solution can result in gas bubbles forming at the electrodes, metal being deposited on the electrodes, and a shift in the solution's color. All of these reactions are triggered by the electric current in the solution. This is an instance of electrolysis. Electrolysis of water is an incredible process in which an electric current is passed through the water, resulting in it being split into hydrogen and oxygen gases. The oxygen is produced at the electrode attached to the positive terminal of the battery, while the hydrogen is created at the electrode connected to the negative terminal of the battery. This method has many uses, such as energy production, water purification, and waste disposal. Electroplating is a widely used industrial process which utilizes the chemical effects of electric current to apply a layer of metal on another material. The piece of material is connected to the negative terminal of the electric current, whereas the corresponding metal is connected to the positive terminal. When an electric current passes through the solution, the metal from the positive terminal is deposited on the object. This process can be utilized to provide a protective coating of various metals on objects, for decorative purposes or to enhance the properties of metals. Electroplating is a process used widely in industry to coat metal objects with a layer of desired metal. It is used to protect metal objects from corrosion and to give them a shiny and aesthetic look. One common application of this technique is chromium plating, which is used for objects like car and bicycle parts, gas burners, wheel rims, etc. Similarly, jewelry makers electroplate less expensive metals with gold and silver to give them the appearance of precious metals. Tin plating is another common application where tin is applied over iron to protect the underlying metal from corrosion. Lastly, iron objects are electroplated with zinc for rust-proofing and protecting against corrosion. The various applications of electroplating demonstrate its importance in industry and manufacturing. I thank you for your attention.